What was the ancestral human diet? My name is Peter Ungar. I'm a paleoanthropologist at the University of Arkansas. I study human evolution, and more specifically, I reconstruct the diets of our ancient ancestors. People often ask me what the ancestral or natural human diet is, or was. And this is an issue that's been debated for literally thousands of years, often framed as a question of the morality of eating meat. The lion has no choice, but we do. Take, for example, Pythagoras, not only the patron saint of high school triangle formulas, but also of ethical vegetarianism. And he once wrote, "Oh, how wrong it is for flesh to be made from flesh." And the argument hasn't really changed much for the last 2,500 years. Only today, we also have Sarah Palin, who wrote in Going Rogue in American Life, "If God had not intended us to eat animals, why did he make them out of meat?" She actually has a point, whether or not you agree with it. When we look at fossil sites like Olduvai Gorge in Tanzania, we see bones eroding out of the ground, covered in the telltale scars of butchery, cut marks all over them. There's very little doubt that our ancestors ate meat millions of years ago. But we also have sites like Ohala 2 on the Sea of Galilee in Israel. We have the wild ancestors of wheat and barley and rye. People were eating these 10,000 years before the origins of agriculture. During the peak of the last great ice age, there's nothing unnatural about gluten either. And in fact, when we look at Neanderthal teeth, we find buried deep within the tartar on those teeth, the little granules of starch, of barley. So all this despite the pervasive call today to cut carbs. And this brings us directly into the heart of the matter, the Paleolithic diets of today. People who advocate for these diets argue that we should be eating more like our ancestors ate. Just as you wouldn't put regular fuel in a car built for diesel, you shouldn't be eating foods that we're not evolved to eat. So whether you're stuffing your face or filling your tank, the wrong fuel can wreak havoc on the system. And according to these diet gurus, many of the chronic degenerative diseases we face today, not just obesity, but heart disease, type 2 diabetes, several forms of cancer, can all be linked to a mismatch between what we eat and what our ancestors evolved to eat. What do these Paleolithic diet gurus tell us to eat? Well, we should be getting our protein from grass-fed cows and fish. We should be getting our carbohydrates from non-starchy vegetables and fruits. What we shouldn't eat is breads and legumes, dairy, potatoes, any kind of highly processed or refined foods. Those are out. Now, I'm not a dietitian, and I cannot speak with authority about the nutritional costs and benefits of either of these diet types, but I can speak to the Paleolithic underpinnings of at least one of these diets. The human fossil record dates back about 7 million years. We've got thousands of fossils today representing this time period. We can divide these fossils into roughly 4 groups. The first group I would call Ardipithecus and friends. These hominins, as they're called, lived between about 7 and 4.5 million years ago. They lived largely in the trees of what is today Africa, hadn't yet come down to the ground. Then, around 4 to 2 million years ago, we get the next group, one that we can call Australopithecus. Now, Australopithecus had come down from the trees somewhat, which makes sense in light of the fact that savannas are beginning to spread across the African continent, particularly the eastern and southern parts. Then about 2.5 million years ago, there's a fork in the evolutionary road. In one direction, we get a group called Paranthropus, our near cousins. These hominins were extremely specialized. Big, heavy skulls, thick jaws, powerful chewing muscles, suited to life in the open savanna. And in the other direction, we get our own ancestors, the biological genus Homo, where we've got wimpier skulls, smaller teeth, but a growing brain over time. So how do we reconstruct the diets of these hominins? Well, I look at their teeth. Teeth are the most commonly preserved fossils. They're the hardest. They are the most durable. And they're the only durable parts of the digestive system that preserve and actually come into contact with food during life. So if we can learn something about the diets of our ancestors by looking at their teeth, we can say something about food preferences in the past. How do we do this? Well, we look at the sizes, shapes, and structures of teeth of living primates and try to relate those to their diets so we can go back to the fossils, look at their teeth, and infer diet. On this image, for example, we have 3 monkey species. At the bottom, we have a langur, in the middle, a macaque, and in the top, we have a mangabey monkey. The langur eats leaves, the macaque soft fruits, and the mangabey, at least on occasion, hard foods like nuts and bark. And we can see these differences reflected in the shapes of their teeth. For example, the langur has long, sharp shearing blades for slicing or shearing through tough leaf material. The mangabey has blunt, flat, thickly enameled teeth for crushing hard foods. And the macaque is somewhere in the middle. Now, this can teach us something about what our ancestors were capable of eating, but not necessarily what they ate on a daily basis. For example, the mangabey at the top only eats hard foods a couple of months out of the year typically, when their preferred foods, soft fleshy fruits, are just not available. Nevertheless, they have to be able to eat these kinds of foods to survive the lean times. So they have to have teeth capable of this. But how do we reconstruct the diets of our ancestors on a daily basis, what they ate regularly? Well, we use what I call food prints, which are like footprints in the sand, traces of the actual activities of once living organisms. And the food print that I look to is one called dental microwear, the microscopic scratches and pits that form on a tooth as the result of its use. So if you look at the top image, you see a microscopic wear surface of a capuchin monkey, which eats hard foods like nuts and seeds. It's covered in pits or craters. On the bottom, we see the microscopic wear of a howling monkey that eats leaves. Its teeth are lined with long parallel scratches. Turns out that the teeth of the capuchin monkey are pitted because they crush those hard foods, whereas the teeth of the howler monkey are scratched because as their teeth slide together in shearing, the abrasives in the leaves get dragged along the surface of the tooth, causing those long parallel scratches. Now, engineers call the top surface complex and the bottom surface simple, because all the features on that bottom surface are roughly the same size and shape and orientation. Okay, well, now let's go take a look at our actual ancestors. We start with something like Ardipithecus that lived, again, 7 to about 4.5 million years ago. Its teeth are fairly conservative. The enamel is reasonably thin. It's got moderate length crests. The teeth are fairly small. It's pretty much what you'd expect of a soft fruit eater. But then when we get to Australopithecus, and particularly Homo, the teeth are getting larger. The enamel's getting thicker. Their surfaces are getting flatter. We're seeing more and more specialization. But when we get to Homo, the teeth get smaller. The enamel gets thinner. The crests get shorter. It's almost a reversal of trends. So when we look at this along a timeline, we start with something that looks essentially like a soft fruit eater in a closed forest. And then over time, from early Australopithecus to late Australopithecus, and into Paranthropus, we see progressive specialization for savanna foods, hard and brittle, or perhaps tough and abrasive. But then this fork in the road about 2.5 million years ago with our own ancestors. The teeth get thinner, smaller. The brains get larger. We start to see meat entering in the record, at least judging from the cut marks on the bones found alongside these ancestors. What do the footprints teach us? Well, on this slide, what we have is we have 3 different types of hominins. We have the Australopithecus group in red, our own ancestors, Homo, in blue, and the Paranthropus group in green. This is from my own research. Lower values, and this is micro-aware complexity, lower values indicate softer foods, higher values, harder foods. And what we see immediately is that Australopithecus had a fairly narrow range of foods, at least judging from this evidence, mostly soft. But when we get to Homo, the early Homo, the first one on the left, and then particularly later Homo, the breadth of diet seems to be getting greater and greater. Paranthropus is also interesting. The first species there has a fairly narrow range of diets, much like Australopithecus, but the second species has a much broader range of diets. Pretty much what you'd expect of a mangabey, that sometimes eats hard foods, but sometimes eats softer foods. So when we break this apart, and we start with the diet of our own ancestors, we see a progressive broadening over time, from early to late Australopithecus, and then early to later Homo. And when we look at Paranthropus, we see also a broadening of the diet in part. But in one species, we see a much narrower diet. So basically, you've got these 2 Paranthropus species with the same shaped teeth, the same shaped skulls, but very different diets. One very narrow, the other very broad. And what this tells me is that tooth shape alone is not enough to predict diet. There's more to diet than the shapes of your teeth. And this introduces the concept that I call the Biospheric Buffet. I think of the biosphere, that part of our planet which harbors life, as a giant buffet of sorts. Animals belly up to the sneeze guard with their plates in their hands, and they pick and choose from whatever foods are available to them at a given time and a given place. Yes, teeth are important. They're the utensils that you have to eat with. But they're not enough to tell us, at least their shapes, what animals eat. Availability is key. This explains why a chimpanzee in the forest eats forest foods, why a baboon, or in this case, a gelada monkey, eats savanna resources. Yes, their teeth are important, but they're not enough. And this is especially relevant when thinking about human evolution, because climatologists teach us that environment varied over time dramatically. It swings back and forth from cool and dry to warm and wet during the course of human evolution. And with those swings in climate come changing availabilities of different kinds of foods. There is a trend over time, cooler and drier through human evolution, which explains the spread of savannas across eastern and southern Africa. But there's more than that. There's also an increase in the amplitude of the swings, in the intensity of the swings. And many people, including me, have argued that it is that sort of changeability in the environment, that variation, the variability in the environment that has made us human. It's selected for our flexibility, our versatility. So let's go back to the original question. What was the ancestral human diet? Well, in light of what we've learned, the question itself really doesn't make a lot of sense. Our lineage was a work in progress, right? Our diets varied over time and space with shifting availabilities of different kinds of foods. And in fact, this is what allowed our ancestors to find something to eat no matter where they roamed, whether it's up in the high Arctic, where nearly all of their food was marine mammals and fish, or down by the equator, where they could take 70% of their calories from sugary melons and starchy roots. In effect, our evolution has prepared us for a versatility that's allowed us to take over the world. So in the end, when I think about the evolution of human diet, when I think about the Paleolithic diets, I don't think about planning our menu for today. I think about the versatility, the flexibility that our evolution has prepared us for. We can eat the good, we can eat the bad, and we can eat the ugly. This versatility is, to me, what defines us as humans and is the key to our evolutionary success. Thank you.